Hey YouTube, how's everybody doing? Welcome to problem 5 out of 25 for our Power 25 series. If you guys have not watched the previous problems, I'd highly recommend it. Basically what the Power 25 series is the 25 most foundational and essential problems to get you started with LeetCode and to kind of nail these software engineering interviews if you're on a time crunch and you need 25 problems to serve as your foundation. So without further ado, let's go ahead and get started. So today we're going to do palindrome linked list. This is by far one of the most essential problems because it teaches two very important algorithms for kind of linked list data structures. And yeah, let's go ahead and get started. So given a singly linked list, determine if it is a palindrome. So first off, we needed to define what a palindrome is. So a palindrome you can think of is if you read it from the kind of start to finish, it will be the same if you read it from the finish to start. So what do I mean by that? So everybody kind of knows the term race car, right? So if you do race car, it's RACECAR. And if you kind of read it from the back, it's the same thing. So race car is also RACECAR. So they're basically saying, if you read it from the front and you read it from the back, is it going to be the same? And here this is false, right? Because 1, 2, if you read that from the front, it's 1, 2, and then if you read 2, 1, that's not the same, right? So 1, 2 doesn't equal 2, 1. Here this is true because 1, 2, 2, 1, if we start going in this direction, we get 1, 2, 2, 1, and that will be true. So you're saying, okay, that's very trivial, right? So if we just reverse the palindrome, say for like a string, all we would kind of need to do is kind of, iterate backwards and see if it's the same as the forward, right? But the problem arises due to the data structure of a linked list, right? So let me just go to the whiteboard of these examples. These are custom examples that I've kind of made that return true. Well, for a linked list, a singly linked list, right, this data structure, we only have access to the next object, right? So how are we going to know to go backwards to kind of map it out in that sort of fashion, right? So it does get a bit tricky. So that's kind of where people get stuck because this is very trivial, right, what we're doing, but it might get a little bit hard for the implementation. So how are we going to go about this? So notice that we have two examples here, and we should pay attention to this. So the first example, we know that the numbers here are an even amount of numbers. So 1, 2, 3, 3, 2, 1, okay? And this is an odd case, 1, 4, 5, 4, 1, and both of these cases return true, right? Because if we read this from the back, it's 1, 2, 3, 3, 2, 1, and 1, 4, 5, 4, 1, the same as the front. So naively, right, we can sort of recurse through them, right, all of them. We can just keep going, and then when we recurse back, we can kind of keep a tab of all the elements that we've seen, but that's not that that's not really that efficient in terms of time and space, right? So what's a very nice way to kind of do this? So what I propose is a very important algorithm that you should learn for linked list is called the slow and fast pointer, or the tortoise and the hare algorithm. So what does that mean? Notice that we have S and F. These are two pointers, and if we traverse them at different speeds, this is what the algorithm is going to look like. So my proposition is we can sort of iterate the slow pointer to become the midpoint of our linked list, right? We reverse the second half of the linked list, and then we compare this to this. So same thing with the 1, 4, 5, 4, 1, right? We would basically, this is the 1, 4, our slow pointer will be at 5, right? And what we basically do is we reverse, so we sort of have we take the reversed half of this, which is 1, 4, 5, and then we compare these two values. So we would iterate toward the halfway point, reverse the second half of the linked list, and then compare that reverse second half to our original pointer with our head node. So if that doesn't make sense, we're going to go through it line by line of how this is going to get implemented. So the slow and fast pointer algorithm is really essential, right? Because we're basically just traversing these pointers at different speeds. So what do I mean by that? We can iterate slow, sort of one at a time. But every time we iterate slow, we would iterate fast twice the speed. So if they're both starting at the start, and we iterate fast twice, and then we iterate slow once, so we keep going until the fast or the fast.next property is none. So what do I mean by that? So now, right, so then slow is going to be here, and then fast is going to be here, okay, and then we're going to keep going, slow is going to be here, and then fast is going to traverse twice, right, and it's going to be none. So the fast pointer here is actually none, so that's good and all. However, if we do this case, we sort of traverse fast, so the fast is going to go on the 5, right, and then the slow is going to go on the 4, the fast is going to go on the 1, right? And then the slow is going to go on the 5. Notice how in the odd case, the fast.next is going to point to none, right? Whereas in this case, the fast was here, where in the other case, this fast.next will actually be none. So we not only need to check if the fast pointer itself is none, but if the fast.next attribute of that pointer is also none. So here we notice that the fast.pointer is none, so we're going to stop. All we're doing here is using the slow pointer to find our midpoint of our linked list. So we have our midpoint of linked list, that's awesome. And we have our head pointer, which is sort of, we still are going to use that as reference. So we have two variables. We have our slow pointer, or we have three, our slow pointer, our fast pointer, and our head pointer. So once we're done with that, all we're basically going to do is reverse the linked list, right? So now our slow pointer, right? So since, let's say we have this example, right? And our fast pointer is none. We have this entire head. This is still our head node. And our slow pointer is now at 3, 2, 1. So now we just need to reverse this part of the linked list. So how are we going to do that? We'll walk a bit more of that in our code implementation. But long story short, we can reverse the sort of linked list in place. And we can say that this guy dot next is going to be none. And then sort of in place. So then the 2.next is going to be none. And then the 1.next is going to be the previous. So that sounds a little bit kind of tricky. We will walk through that during the code implementation. But after we reverse the linked list, we have these two pointers, right? So let's say we have P as our reverse sort of pointer, and we have our head, which is still the original 1, 2, 3, 3, 2, 1. And now, since this part is reversed, we just iterate. So we kind of check this guy, and check this guy. And if this guy runs out, like if the first half of our linked list compares with our reverse portion, then we know that it's true, right? So if we sort of reverse these numbers and it checks out with the first half, we know that we found a match. And this is awesome. So we did two awesome algorithms here. We did the tortoise and the hare pointer, the fast and the slow pointer, and we also reversed the linked list. So this is the high-level implementation of how it would work. We would return true. You know, if we have something that is not does not check out, so we have like a 4, 2, 1, we reverse this part and this becomes a 1, 2, 4, right? And then we compare like the 1, 2, 3 with the 1, 2, 4. This checks out, that is not a match. We're going to return false. But this is awesome. This is sort of the high-level overview, and now we're going to go ahead and jump into the coding implementation. All right, awesome. So now let's go ahead with the coding implementation. So sort of our step 1 is we need to find the midpoint, right? So we're going to find sort of the midpoint of our algorithm. So how are we going to do that? So we're going to do like we did in the coding walkthrough. We're going to do fast is equal to slow is equal to head. So we're establishing two pointers along with the head. And all we have to say is, well, fast and fast.next is true. We're going to iterate fast twice, right? So fast is going to equal fast.next, and slow is going to equal slow.next. So now we found the midpoint. So the midpoint is sort of going to be our slow pointer. We know that in both cases, our midpoint, like let's say here, our midpoint is going to be here, and it's going to be slow. So our midpoint is slow, and then our midpoint here would be on the 3, which is also the slow. So now since we found the midpoint, step 2, and this is what we'll explain a bit more, is we're going to reverse the linked list. So we're just going to say our previous. This is a very great way of how to reverse things in place. So we have this previous while the slow. Our temp is going to equal the slow pointer. Our slow is going to equal the slow.next. And our temp.next is going to equal to previous, sort of reversing it in place, and our previous is equal to temp. So this sounds really confusing. What do I mean by what I'm doing here? Let's say that we have 3, 2, 1, and we want to reverse it. Our previous is going to be none right now. And all we do is we have a temp pointer and sort of the pointer we're iterating on. So slow and temp, right? So our temp is going to be here, and our slow is going to equal to slow.next. So how are we going to reverse this? So we're saying that the temp.next is going to equal to prev. Previous is our none right now. So this is going to be a 3, and it's going to point to nothing. We're going to iterate both of the pointers, temp, slow. Our temp.next is going to equal to prev. What is prev right now? Since we set our prev equal to temp, our prev is basically the 2. Our prev is this box, setting to nothing. We iterate again, our temp, and then our slow. And this guy, .next, the temp.next, is just going to equal to prev. And our prev is now this box. And that is the exact data structure of the linked list. And now we have our previous element which has reference to 1, 2, 3 in that manner. And that is a very elegant way of how to reverse a linked list in place. So now we reverse the linked list, and now we just need to compare the first and second half. So while our previous, right, so we still have this 1, 2, 3, and like for this example, we're comparing the first half, so 1, 2, 3. So now we just need to go side by side and compare them. So while previous, if the previous dot value is not equal to the head dot value, what do we do? No, we just need to return false, because that is not going to work. And else, if it does, that current value passed a check, we're going to iterate both of them, just head dot next. And if both of these run, if both of this iteration runs through and everything is fine, we're going to return true, because we know that we mapped through all of the values and we said, okay, this is a match. For this example, we're comparing 1, 4, 5, right, the first half, with the reversed half of 5, 4, 1, which is also 1, 4, 5. And these are going to compare side by side, and we're going to return true. And let's go ahead and run the code and see what happens. So let's see, we got a quick error. We actually traverse the slow.next twice. We should just traverse it one time, right? Because this is moving twice the speed and that's moving the first time. So let's go ahead and see if that works. And boom, just like that, we got accepted. This is the step 1. We need to find the midpoint. We need to reverse the linked list sort of after the midpoint, so the second half. And then we just compare step 3, compare first and second half. But yeah, guys, so that's basically it. Thank you so much for watching, and I will see you in the next video.